Hi everyone. I want to take this opportunity to just talk a little bit about Module 12, Thinking Tools. In this video, I think I'm just going to show you a bunch of resources because I do think the thinking tools are extremely important, and I think that there isn't enough resources kind of made available to us directly at the intermediate level. So I just want to show you where some cool places are to think about some thinking tools. So first, Desmos I already talked about a little bit, but I just want to show you what it can do. So Daniel brought up the TI Inspire calculator, which is a really cool tool, but not a lot of schools have them. A lot of schools are still stuck with the 83s, which I would never use just because they're intuitive. They're not intuitive anymore. Instead, I would use Desmos. Say that I want to have my students explore the different parameters that have an effect on a straight line. So we talk about the fact that a straight line can be y equals something x plus something else. Now, we might not call it ax plus b, we might not call it whatever. And I would also have my students explore a lot different growing patterns so they come to the realization that it's always something times x plus something else. And now I want to look at a graph and the abstract meaning of what that does. Well, Desmos, as soon as you add parameters that aren't x and y, it asks you if you want to add a slider. And so I'm going to say all. And so this is what happens. So this is what this line looks like when A is 1 and B is 1. And now if I want to change A, that's what happens. And if I want to change B, that's what happens. So I think that's pretty impressive for about a 5-second investigation. I'm going to show you what else it can do at the intermediate level. So grade 10, we can do the same kind of thing. Like that with a parabola. And again, I said add all sliders. And now what happens when I change the H? And what happens when I change the K? So I think that's pretty impressive. And if I want to add an A to see what happens if I add a multiplier, well, that's what happens, right? So the cool thing too with Desmos is that I can also add an image to be my background, and then I can have my students match this parabola to that image, right? So they're exploring really what A, H, and K do in the context of trying to match something engaging. So that's desmos.com, the calculator. I'm going to show you also, this is teacher.desmos.com. It comes with a whole host of ready-made teacher activities for students to do. It's actually headed by Dan Mayer, whose TED Talk you watched a little while ago. But this is just one example of an activity. It's called Match My Parabola, and students have to go through and they have to make a parabola that goes through these 3 points. So they have to write an equation of a parabola, go through parabolas that they'll have to go through parabolas that go through all of these. So they have to do this, and as a teacher, you can see what everybody's doing, and you can kind of you can keep up with that. Okay, so that's what teacher.desmos is. I now wanted to just talk about Algebra Tiles for the rest of the time because I think that Algebra Tiles are extremely important for students. And I think that we don't use them enough. The reason why algebra tiles are important to me is because remember when we talked about big ideas, I said that pictures have to match words, have to match graphs, and everything has to tell us the same story. Well, in algebra is so abstract that we often get away from the picture that it makes. But the way that algebra was actually first discovered was by people looking at pictures and rectangles and the differences between rectangles, and they didn't want to deal with these differences in measurable items, so they called it like this rectangle plus x, or the length of this rectangle plus x and the width of this rectangle plus y, and so that became the x and the y factors. So if you take a look at trying to factor that I posted on the same thread that I'm going to post this video in. And I made this for my students a while ago. I don't show this to them anymore. I now do a discovery activity, and then they watch at home as like a little summary. But you can see that if I have, so this is an x squared tile. These three are x tiles. These two are x tiles. They're just laid differently. And then these are unit tiles. So this shows us x squared plus 5x plus 6. And if I want to turn that into a rectangle, this is the only possible way that I can do it. And what that shows me is that the length of this rectangle is x plus 1, 2, 3, and x plus 1, 2. And if you want to see that more in depth, just watch the video that I posted. But that shows us that actually x squared plus 5x plus 6 can be broken down into, if we think of it as length times width for a rectangle, it's x plus 3 times x plus 2. And so that's how we factor with Algebra Tiles. And the activity that I would have my students do, I'll also post it for you in the thread. And it's this activity right here, where they would just get to mess around with Algebra Tiles a little bit and try to write some stuff down, and then try to develop a pattern. And at the end, they try to use this pattern. So that's what a lot of my lessons end up being, is students just messing around with manipulatives until they discover something that I'd like them to discover, and then they try to use it. So that's that. I'll show you one other really cool thing. I also posted this activity, which is an activity on completing the square, which is a pretty complex idea in grade 10 math. But when we use Algebra Tiles, and again, you can just do this activity if you want at home, but when we do it with Algebra Tiles, it actually comes down to visually, you have a square with a missing piece. And what completing the square is just adding in whatever you need to complete that square physically. So I think that this activity also is why I really like Algebra Tiles, because it leads to understanding of that. And the final thing that I want to show you is this activity here in paying attention to algebra. And this is something that I do with even my grade 11 students. It can be done with grade 10 applied or academic students, but I also do it with my grade 11 students. And it uses linking cubes to discover something about quadratic growing patterns. So again, you can try the activity at home. What I do is I give my students this picture and this picture, and I say, this is image 2 and image 3. And then I want them to develop image 1 and image 4. And then what I want them to do is I want them to build these images out of linking cubes. And then I have them separate the linking cubes and stand them up so that the black ones are on the bottom, the green ones are in the middle, and the orange ones are on the top. And what they quickly realize is that a quadratic function can be made up of constant parts. So you can see the oranges are constant, the greens are linear parts, and then the blacks are quadratic parts. So that's pretty interesting in terms of math, is the fact that within a quadratic, we have a quadratic, a linear, and a constant. And that goes along with some other of our big ideas that we want to discover going into grade 11. So that's also in the post that I'm making. Okay, so I hope that that gives you lots of ideas. Again, it's just not enough time to kind of show you everything that there is to know, but I hope that that gives you a good starting point so that you can kind of start to discover the different things that you can do. Starting point, I think teacher.desmos.com will give you a fantastic starting point to start with digital thinking tools. Okay, and then the next part I would definitely say is Algebra Tiles, starting grade 7 and grade 8, and going into grade 9 and going into grade 10. Okay, that's all, and we'll talk again, module 13.